So now let us see Wolff-Kishner reduction. So it is a chemical reaction where carbonyl group is converted to methylene group. Carbonyl group is present in aldehyde and even in ketones. Only aldehyde and ketones are converted into their respective methylene groups. So here we will be taking a substrate which is acetophenone. So this is acetophenone. When it reacts with hydrazine, that is acetophenone and hydrazine, when they are heated at 197 degrees Celsius in the presence of a strong base KOH. That is, this whole reaction, it takes place in basic medium. So in the presence of a strong base KOH and a protic solvent ethylene glycol, which is CH2, OH and OH. So this is ethylene glycol. We will be getting ethyl benzene. So this is ethyl benzene, 2 hydrogens. And N2 over here. N2 is eliminated. So here you can see this is carbonyl group. This carbonyl group is converted into methylene group. That is, reduction of carbonyl group into methylene group is taking place. Double bond O, breaking of double bond O, and formation of 2 CH bonds are seen in this reaction. So now let us see the mechanism. So in mechanism, there are two major steps, two main steps, which are first one is the formation of hydrazone, acetophenone hydrazone, and then is the formation of a product which is ethyl benzene. This is hydrazine. So yeah, now let us see our first step, which is the formation of acetophenone hydrazone. So here acetophenone, it will react with hydrazine in the presence of a base KOH. So first nitrogen, it is an electronegative atom, so it will take electrons from hydrogen and proton is eliminated. So now this proton is attacked by the lone pair of electrons present on oxygen, forming a bond between oxygen and hydrogen, where oxygen here will get a positive charge. Oxygen usually forms only 2 bonds, so as it is forming 3 bonds, it will get a positive charge and will be having NH2 and a negative charge on nitrogen. Now as oxygen is more electronegative than carbon, it will take the electrons from carbon, that is, this bond is shifted over to the oxygen, leaving this carbon positively charged. So the structure we will be getting here is carbon with a positive charge. Now nitrogen, it will share its extra electrons to the positively charged carbon, forming a sigma bond between carbon and nitrogen. So a sigma bond is formed between carbon as well as nitrogen. So the structure we will be getting here is here OH, CH3, the bond between carbon and nitrogen, H and NH2. Now again, nitrogen will take the electrons from hydrogen, proton is eliminated from here, then again oxygen will share its electrons with the positively charged hydrogen, that is proton, forming a bond between oxygen and hydrogen again, giving us a water molecule over there. So here we'll be getting OH2 and a positive charge on oxygen. Here nitrogen will have a negative charge. So now again, in order to neutralize its charge, it will take electrons from carbon, and will leave the compound as water molecule. Carbon here will get a positive charge. Then nitrogen will share its electrons to the positively charged carbon, forming a double bond between carbon and nitrogen. So here double bond between carbon and nitrogen, and this is NH2. So this is our acetophenone hydrazone. You can see here the conversion of hydrazine to hydrazone. So now let us see our second mechanism, which is the formation of ethyl benzene. Formation of ethyl benzene. So again we will take acetophenone hydrazone. So this is acetophenone hydrazone. In acetophenone hydrazone, the NH2 group present over here is acidic. So in order to remove protons, we will be requiring a strong base. So the strong base that we will be using here is the conjugate base of our protic solvent, that is ethylene glycol. So what is the conjugate base of ethylene glycol? So there are two OH groups in ethylene glycol. So when one of the OH group, that is one of the hydroxy group, it will remove its proton, that is if one of the proton is eliminated from the hydroxy group, then that compound is considered to be our conjugate base. So this is our conjugate base. Now by using this conjugate base, we will be removing the protons from this acidic group. So first we will be doing deprotonation. Deprotonation in the sense nothing but removal of hydrogens. In the presence of conjugate base, so what happens here? Nitrogen and two hydrogens. Nitrogen will take the bond, will take the electrons from hydrogen. H plus is eliminated. Now this H plus and conjugate base of ethylene glycol, they get removed as ethylene glycol. Okay, ethylene glycol is eliminated, that is H plus will form a bond with the negatively charged oxygen and will give us a compound where nitrogen will be carrying a negative charge. Nitrogen is having a negative charge. Now this negative charge is shifted over here, forming a double bond. Then this nitrogen will get a positive charge. So now in order to neutralize its charge, nitrogen will again lose its electrons to the carbon. That is, the bond is shifted over to the carbon, forming a negative charge on carbon, and a double bond is formed between the two nitrogens. Now here the double bond is formed between two nitrogens. Here a negative charge. Now to this negative charge we should add a proton. So again we will be doing protonation. So protonation will take place in the presence of ethylene glycol. So here we will be using ethylene glycol directly. So what happens? Here oxygen will take the electrons from hydrogen. Proton is eliminated. Now negative charge is shifted over here, forming a bond with carbon and hydrogen. Bond is formed between carbon and hydrogen. CH3, here double bond NH, hydrogen. So now to this compound again we will be doing deprotonation. We need to remove these acidic hydrogens. So in order to remove even this hydrogen, we will be doing deprotonation. In the presence of conjugate base ethylene glycol. So ethylene glycol can be written even in this form. So first nitrogen will take the bond, H plus is eliminated, H plus and conjugate base, they come out as ethylene glycol, and then the compound we will be getting here is nitrogen with a negative charge again. Here a negative charge and here hydrogen. Now in this step you can see elimination of N2. That is N2 is eliminated, nitrogen gas is eliminated. This negative charge is shifted over here, forming a triple bond between nitrogen. So usually nitrogen forms triple bond. Its valency is 3, so it forms triple bond. N2 is eliminated. Then the extra electron present on nitrogen is shifted over to the carbon, forming a negative charge on carbon. N2 is eliminated and giving us a structure here where carbon will attain a negative charge. So this is CH3, a H over here and a negative charge on this carbon. Now again we will be doing protonation in the presence of ethylene glycol, 2 hydroxy groups over here. Now oxygen electronegative charge, electronegative atom, it will take the electrons from hydrogen, proton is eliminated. Now this proton bond is now this negative charge is shifted over to this proton, that is a bond formed between carbon and hydrogen, giving us our final product, our ethyl benzene and 2 hydrogens. So carbonyl group is converted into methylene group. So this is ethyl benzene. So this is a mechanism for Wolff-Kishner reduction.